Hello everyone, welcome back to Bleed Electrical. This is course on energy management and audit, and I am Triveli Naidu from the Department of Electrical Engineering at St.Vincent College of Engineering and Technology, Nagpur. In the previous video, I have already explained you regarding energy benchmarking. If you have not watched the previous video, you'll find the link for this video in the description box. Now this video is all about plant energy performance. So let's get started. We'll be discussing on energy performance. So what is this energy performance in a plant? Plant energy performance is the measure of whether a plant is now using more or less energy to manufacture its product than it did in the past. I'll be comparing the plant energy performance this year with the last year or the reference year. I would be more or less keeping a check on energy consumption pattern and the production rate of the industry in order to obtain this plant energy performance. Then plant energy performance is a measure of how well the energy management program is doing. So if it works out really well, then we say that the plant energy performance is good. Otherwise, we need a check on the energy management system. Then it compares the change in energy consumption from one year to the other year, considering the production output. As I already told you that whatever energy consumption was there in the reference year and whatever amount of production I achieved, the same should be done in this year also. So same energy consumption should give you the same production. Then I say that the plant energy performance is 1 or it is 100%. If I achieve more production, then it is well and good. Yes, so this is what is plant energy performance. Then plant energy performance monitoring compares plant energy use at a reference year with the subsequent years to determine the improvement that has been made. Now, what is this production factor? Production factor is the ratio. Ratio of what? It is the ratio of production in the current year to that in the reference year. So whatever production you are having right now, when compared to your reference year, will give you the production factor. So it is very essential or a crucial part when you want to analyze your energy performance. Then energy performance. In energy performance, what is this reference year equivalent energy use? Now what is this reference year equivalent? The reference year's energy use that would have been used to produce the current year's production output may be called the reference year energy use equivalent. Now I know last year's data I already have. I know this was the consumption last year. So this year I have a clear picture of how much energy I have to use in order to particularly have a production rate as I had in the last year or in the reference year. In fact, I would try to have a more production rate in my industry. Okay, so that is how the reference year's energy use is helping you out. Okay, then the reference year equivalent is obtained by multiplying the reference year's energy use by the production factor. Means what happens? Reference year equivalent is equal to the product of reference year energy use and the production factor. So this is how you can find out the reference year equivalent. And finally, the improvement or deterioration from the reference year is called the energy performance. So you can now find out how well your industry is flourishing or performing, or how bad your industry is doing when it comes to energy management progress. So now this plant energy performance is given by the formula reference year equivalent, as we discussed, minus current year's energy upon reference year's equivalent into 100. So this is how we can find out plant energy performance. Now, matching energy use to requirement. Obviously, the requirement is more and more and the energy available to us is less. So, there is a mismatch. So, mismatch between the equipment capacity and user requirement often leads to inefficiencies, and inefficiencies due to part load operation and wastages, etc. So in order to control all these things, we can do certain things, okay, in the industry. So some example being eliminate throttling of a pump by impeller trimming, resizing pump, installing variable speed drives. Another thing could be eliminate damper operation in the fans by impeller trimming, installing variable speed drives, pulley diameter modification for belt drives, fan resizing for better efficiency, then moderation of chilled water temperature for process chilling needs, then recovery of energy lost in control valve pressure drops by back pressure or turbine adoption. Then lastly, adoption of task lighting in place of less effective area lighting. So these could be the examples in order to have maximize energy used, okay, in order to avoid the wastage in the industry. So how to maximize system efficiencies? First of all, you can eliminate steam leakages by trap improvement, because leaks are expensive. You have to fix them. Otherwise, the steam will be wasted. Then, maximize condensate recovery. We'll be talking about this further in unit number 3. We'll be discussing about waste heat recovery theory. So, we'll be talking about this in the coming lectures. Then, adopt combustion controls for maximizing combustion efficiency. Then, ensuring rated electrical parameters at the motor terminals. Then replace pumps, fans, air compressors, refrigeration compressors, boilers, furnaces, heaters and other energy consuming equipment wherever significant energy efficiency margin exists. Now talking about optimizing the input energy requirements. Optimizing the input energy requirements consequent upon fine-tuning the energy use practices, then attention is accorded to considerations for minimizing energy input requirements. So the measure that you could do in order to optimize the input energy requirement could be shuffling of compressors to match the needs. Then periodic review could be done of insulation thickness. You could identify potential for heat exchangers, networking and process integration. Then optimization of transformer operation with respect to load. Now fuel and energy substitution. What is this fuel and energy substitution? Substitution is nothing but replacement. Replacement with a certain apt, certain thing which could be replaced. Okay, now fuel. If we talk about fuel, what could be the thing? We can replace the fossil fuels with the more efficient ones so that your cost is less, you have less polluting fuel. You can replace it by biogas and locally available agro residues. Then, to reduce energy dependency, we could do either of the two things. We could have energy conservation as we have already discussed, and we could have energy substitution. So to understand this better, let us have a view at the examples of these two. Now, if I consider the example of fuel substitution, natural gas is increasingly the fuel of the choice as fuel, and feedstock in the fertilizers, petrochemicals, power, sponge, iron industries, then replacement of coal by coconut shell, rice husk, etc. Replacement of LDO by LSHS. Then few examples of energy substitution could be replacement of electric heaters by steam heaters, then replacement of steam-based hot waters by solar systems. So that's all for this video. We have discussed about the plant energy performance. In the upcoming video, I'll be talking about the energy audit instruments. So keep watching. Thank you.